All right, so you must be thinking, I think he's confused about where he is. But the reason I have this is because really we used to see this a lot where we might have an ecosystem where the core was built in a compiled language like C or C++ for speed and performance needs, but then we had a lot of Python kind of nestled in the perimeter to really give the community a high degree of developer productivity. That is really until our friend took the stage. And what we see now is not only projects where Go is the sole language in the project, but we might have at the core of the project written in a different language. It might be C, C++, Rust, and then the ecosystem that is growing around this project is written in Go. And this is really the story that I want to talk about today. So my name is Jose Nino, and I'm a software engineer at Lyft. And for the past 2 years, I've worked at Lyft's networking team, out of which we have created a C++ project called Envoy. And, but really around this project, we've created an ecosystem, an open source ecosystem, where not only Lyft, but also members from the community have gotten involved. And largely, a good part of this ecosystem is written in Go. So I want to explore a little bit of why I think Go has served as an ideal ecosystem for the Envoy project, and focus this really as how Go has made us very productive and helped create a thriving ecosystem. But before I get into the why, I want to talk a little bit about the what. So as I said before, out of the networking team, we created a C++ network proxy called Envoy, and its main goal is to make the network transparent and observable, which are really crucial elements in today's internet scale companies, which rely on highly distributed systems. But around the C++ project, we have a lot of projects written in Go that have grown our ecosystem. So we have written services that augment Envoy's functionality. So for example, the rate limit system, which thanks to its simple namesake, you might guess it just rate limits the rate of requests that Envoy can make. Or we have also written a lot of what we call control plane servers, which dynamically configure the proxy. But in addition, we have also written libraries and plugins for proto-validation or other core pieces of this ecosystem like Go Stats or Go Runtime that have allowed people to come in and really iterate on the project. So what are some characteristics of a productive ecosystem in my opinion? First, there should be a high degree of knowledge sharing, and this is both a technical problem, but perhaps most importantly, a social problem. It has to be easy for us to build not only projects, but larger ecosystems where knowledge can flow so that newcomers and old-timers alike can produce and share information about what we have built. Second, and related to one of the talks from earlier, we have to give an environment that increases the developer productivity. So we have to give tools and guardrails so that people can iterate on the ecosystem and create new things in not only a fast manner, but also in a reliable and safe manner. And third, and this is related to the highly distributed nature of most of our internet scale companies, different parts of the ecosystem have to be able to talk and integrate with one another in a consistent manner. So let's investigate how Go has enabled us to meet these characteristics in the Envoy ecosystem. So the first thing is knowledge sharing. And really, one of the most obvious ways in which we share knowledge in our industry is through documentation. And Go couldn't have made it easier and better for us to share documentation with the project of godoc.org, which allows us to create packages and then publish documentation to godoc.org so that it's highly discoverable. Additionally, godoc.org really allows us and encourages us to write documentation next to code. So this makes it less likely that the next time that someone comes and iterates on code, they will leave documentation behind or steal documentation, because whenever they go into the code base, they see documentation in line and are encouraged to update it. So for example, here on the right, we have a snippet of one of our projects in godoc.org where we're defining a cache interface, and next to this cache interface, we have documentation on each of the methods of the interface. So whenever a developer comes and adds a new method to this interface, they're encouraged to add documentation, which will then, when merged to master, will appear in go.doc.org seamlessly. And while documentation is important for all pieces of our ecosystem, it's really essential for the libraries that are the building blocks of our project. And so, for example, here is a snippet from the GoStats GitHub project, and all of our GitHub projects have a GoDog little button where whenever a person needs to use this for a new project that they might be spinning up, they can go and investigate all the documentation very easily. So we have talked about sharing knowledge. How about when you've convinced folks to come and invest their time in your open source project, we want to give them the tools and the guardrails so that they can be highly productive in this ecosystem. And this is really where the Go toolchain really shines, because it's really installed on every single Go installation. So it has all the tools that you need to test your code, to inspect metrics about your coverage, to detect data races, and a lot just installed for free. So it really gives a low barrier of entry for everyone in your organization to be able to have the same tools at their disposal. And because of this ubiquitous nature, we can also integrate all of these tools into our continuous integration pipeline. So for example, when someone comes and iterates on code and puts a PR up against your project, we can integrate, for example, coverage with this visualization so that people can know that the code that has been added has actually been tested and covered. So now that I've talked a little bit about knowledge sharing and developer productivity, as I said before, one of the fundamental aspects of this highly distributed nature of our ecosystems is to create ways so that different parts of our ecosystem can integrate and interact with each other. And one of the ways that Go has allowed us to do that in the Envoy project is that protobuffs are really the lingua franca in the Envoy ecosystem. So both from the C++ project to the Go services, all the API interactions happen over protobuf and gRPC. And so a project that we created in this space is called protoc gen validate, which is a protobuf compiler plugin that uses the templating package of Go to create protobuf structs to constrain the fields in our API. So for example, here we see a person message. And additionally, you see that, for example, in the email field, we can add constraints to our APIs so that we not only know that the email field is a string, but also it has to adapt to a well-known pattern that then protoc gen validate can generate stubs for, and we can validate in code. And what's really wonderful about the templating package is that it allowed us to create, at compile time, stubs for both our C++ core and our Go ecosystem. So in one fell swoop, we have the strong constraints both in the Envoy project that is running in C++ and also the surrounding Go ecosystem. And lastly, another example in that really shows how Go has allowed us to create services that communicate with each other in reliable ways is that Go is gRPC and HTTP2 native. So this allows us to use the strong APIs that I was talking about in protobuf, and more importantly, it allows us to do streaming between different parts of our ecosystem. So for example, like I was talking about before, we have created services that configure Envoy dynamically over the wire. So we can speak gRPC between the Go services and then the core of our ecosystem, which is Envoy. So these are just a brief introduction to the examples that have allowed us to create a thriving ecosystem in Go, even though the core of our project is written in a different language. So I hope that I've shown you a little bit and given you a taste for how even a multilingual ecosystem, Go can really come in and help you thrive. So the message that I want to give is that Go is the backbone of the Envoy ecosystem. We might have not written the center of the Envoy project in Go, but just by exposing our ecosystem to Go, we have created an ecosystem where we have a high degree of knowledge sharing, a high degree of developer productivity, and then we have an ecosystem that can interact with each other in a reliable and consistent way. So if any of this is interesting to you, I would encourage you to come to our GitHub orgs, both at Lyft and at the Envoy proxy GitHub org. It's all open source, so if this is interesting to you, come and play with us. Thank you very much.